In this video, we will recap atoms and electrons. Recall the atom. It consists of three major particles: the protons and neutrons, which are both found in the nucleus, which give the atom its mass, and the electrons, which are found in the orbitals, pretty much whizzing around the nucleus at certain distances, forming specific layers. These layered orbitals often are termed as shells. This, of course, is practically physics. As organic chemists, we will not really care about the atom per se. We will care about the specific mass of each element, which is derived from the number of protons and neutrons, and the number of bonds an atom can form. And this is determined by just the outermost electrons, or the valence electrons, which are involved in bonding. Luckily for us, all the information that we need is found in the periodic table. Both the atomic number, which tells us the number of electrons and the number of protons in a molecule, and the atomic mass, which gives us the combined mass of neutrons and protons. As the number of valence electrons is what determines how the columns are formed in this periodic table, it means that we can also tell the number of valence electrons in each column. If we know that, we know how many bonds each element in each column can form. For example, hydrogen, being in group 1, only has one valence electron and therefore can only form one bond. Boron, in group 3, in this case 13, has 3 valence electrons and can form 3 bonds. Carbon, with 4 valence electrons, can form 4 bonds. Because of the octet rule, electrons want to pair up, and therefore past carbon, nitrogen, oxygen, fluorine, and neon, the electrons stop pairing up and are unable to form bonds with those paired electrons, in which case nitrogen can only form 3 bonds, oxygen can only form 2 bonds, and fluoride can only form 1 bond. Of course, if you encounter a molecule with a discrepancy with this number of bonds, it also means that there must be a charge.